Hi, and welcome to a quick tutorial on using TechPlot360EX with Fluent data. My name is Darrell Rittenberg. Thanks for sitting in. We're going to look at an example. I'm going to load the data file. These data are, in fact, a chemical mixer. This is an unsteady solution. We have a moving mesh, and so we have case and DAT files for each time step. I brought in a representative number of time steps. I didn't bring all of them, but there's about 30 plus. So I'm going to select all of them here, and I'm going to add to list, and that's just going to add them in here. And I can, at this point, just click Open. If I did want to specify options, I just have to click on the Advanced Options button and hit Open. It puts all the information in here. The one thing that we're going to do is include particle data. And you can see that what's happening down on the status bar is we're actually reading through, and now we have all those data loaded. You can see it's very fast. This is the top of the mixer. I'm going to hide that so we can look inside. I'm going to make this panel of the mixer translucent by, say, 70% so we can see inside. I'm going to turn off the shade and turn on the mesh for the other zones as well. I could select all of them and operate, but we'll go ahead and do this one at a time. Okay, so this is our model. I'm going to turn off the bounding box. The bounding box is just to give me a quick view of the extent of the fluid domain. Next, I'll go ahead and hide the mesh. Now, this is the part of the mesh that Fluent is using as part of the solution. The mesh is actually changing or moving, so that's kind of the part of the mesh that is moving. So if I hit play, you can see that what's happening is that we're actually mixing the solution. So if we wanted to quickly take a look at the particle information, we're going to go into Zone Styles, and you can see here are all the zones of interest. Under Scatter, I'm going to turn off the scatter for all but the particles and change the scatter shape to a sphere because that's the way I want to look at it. And from a color perspective, let's go ahead and use pressure, which is the first contour variable. Alright, so when I turn on the scatter, you can see there are the pieces of catalyst. In this case, it's a solid catalyst. It's a heterogeneous solution with a solid catalyst. And if I hit play, you can see those particles moving in time. Okay. So what we want to do is, I'm going to go ahead and turn off the shade here so we can kind of look inside here. What I want to do is I want to look at a slice and perhaps evaluate the different components. So this is a slice where we're looking at pressure. It's along the y-axis or the x-axis. Actually, the y-axis is more appropriate for the solution. I'll type y, moving into y. Okay. We also implemented arbitrary. So if I hit A, this is an arbitrary slice, and we can actually move it around in the solution to a place that makes sense. I need this slice to be translucent so I can see the mixer behind it. So I'll turn on translucency. Perhaps 30% is fine. Okay, so there's our slice. We're going to change the variable that's shown in the slice. I want to select the concentration of DPM, and now I can use that variable, so concentration of DPM. Now it looks like there's no DPM at this point. Let's go in and select perhaps a different one. Let's look at the C2H50H. So we'll go ahead and look at that. And it looks like that's also 0. So you can play around quickly with the amount of each one of the species. And so, okay, here's the phase. So we'll go ahead and look at that. All right. It doesn't look like it's changing all that much, but we haven't updated it here. Maybe we want to add some additional contour levels, which you can do by selecting. And I think if we hit play, you can see then that it's mixing. So one of the things that you need to do is go back to that beginning of the solution by hitting play. And so now you can kind of get a sense of the chemical mixing, and you can also see the impact of the catalyst. Okay. Now the first time I go through the play of these data, I'm actually loading in that variable. The second time I go through, it's going to go very fast now that those variables are loaded into memory. And I'm also going to get rid of the contour legends here by just hitting hide. Okay. So this, very quickly, you can see I have a view of the data that might be interesting. I want to have a second view of the data, and I want to create a frame. So I'm going to hit copy. That's going to copy this frame, and I'll just hit Control V to paste it in. I'll then move into the tile frames, and I'm going to just put them side by side. Right now they're not linked, so you can see I can move one around and the other one doesn't move. If I want these to be linked together, I'll go to Frame and go to Frame Linking and 3D Plot View Slice Position and apply that to all frames. Now when I rotate one, it rotates both. To rotate, you just hit Control right click. That'll actually rotate. Right click will translate. The middle mouse button will zoom in and out. Just little tricks of the trade if you're unaware. Alright, so the slice position, if I wanted to change the slice to a Z slice, I can just hit, get in the slice tool, hit Z, and it will move into a Z slice, and you can see that it updated automatically. In this case, though, I want to look at pressure, or maybe I should look at the Y velocity. So I don't have to use the same variable with the two slices. I'm going to move the slice down so it's sitting right on top of the blades so that we can see this a little better. And let's see, let's put it right here. Okay, so now you can kind of see where that's changing. If I want to understand how pressure might be changing or the concentration might be changing as a function of time, I can quickly go to Probe and create time series plot. And then I'm going to select a point on the slice here. And what's going to happen is you'll see that it's actually going through each of the time steps, and it's going to extract the value of what's shown on the slice at that point. And so it will take a second. There's 73 time steps, so it should be going through pretty quickly. And the idea here is that I can create a probe or a plot of a particular value over time. So the first time it goes through, again, it has to load the information necessary to create that point. So depending on the size of your data, this operation could take anywhere from 1 minute to 10 minutes. So we'll go ahead and pause for a second. Okay, it looks like it's done. And so now what you're doing, what you see is a series of values as a function of time. So we're looking at pressure as a function of time. And if we hit play, you can actually see how pressure is changing all the way through the extent of the data. So that's just a quick trick, or not trick, but a quick way of kind of interrogating a particular value. If I click on a different point, it will actually go through, now that the data is loaded, it should be a lot faster, and it will actually pull out that pressure profile, and we can then look at the variance between, visually anyway, what the variance is between the two examples. So depending on the type of data you're looking at, if you're looking at unsteady results, this is certainly a convenient way to evaluate them. Once I'm done, if I assume that this is the plot that I want, and I may want to do some plot smithing, specifically around maybe moving this frame up, and then we will actually make these frames a little smaller, kind of to create a collage of sorts. So let's just make sure we're looking at the right thing here. And perhaps I'll move these closer. Alright. So this is maybe my final image or final layout that I want to print or publish. And what I'm going to show you is how quickly you can do that. So there's a couple of things. On a particular zone or a particular frame, if I right-click on the frame itself, I can copy this and bring it into an application like PowerPoint or Word and just paste it in. If I wanted to save this out as an image, I just go to File, Export, and under Export I would select like a ping for all frames, and I could save this out as well. I can also enter in a width, say if I wanted it to be high resolution, say 2500, and use anti-aliasing. Say OK, and so it's going to put it out, and I'll just put it on the desktop. Or actually it doesn't really matter, but put it right here on the desktop, and we'll call it Untitled 2, and hit Save. And so basically now it's going to render, off-screen rendering, and it's going to dump it onto the desktop. And given the size of it, putting it into this environment is probably not worthwhile, but if you are interested, that's how you basically dump it out. So that's how you use TechPlot 360EX with Fluent data. If you have any other questions, don't hesitate to email us at support.techplot.com or support@techplot.com. Thanks again for watching.